Hi, in this video, we will create a small project on students registration using linked list. When I say linked list, we'll use single linked list only. But in linked list, we have other types of linked list also, like W linked list, circular W. So basically, four types of linked list. But here in this project, I will be using just single linked list or single linked list. So before starting, okay, I'm on my virtual machine and of Linux basically, and let me create a folder here. I say student registration. Let me go inside this. So let me so I don't have anything in this folder. Let me create a file. We will create a single file and we will name it um, student registration.c, and I'm using VEditor to modify this file, and I will say enter. Now I will come in insert mode by pressing I. If you look at the bottom, you will see that insert message. So now let me add basic header files which we need to run this project. So since this is C, we need stdio.h, and we will create a structure, uh, for one node actually. When we say we are uh, writing program using single linked list, we need to create one node. Then that node we can create using a structure. So the syntax is struct, and the name of node, let's say student, and enter. And after this, a node has two portions, data and next part. In next part we store the address of next node, and in data part we can store anything. We can store number, we can store strings, we can have a combination of numbers or strings. So, and we can have a number of elements. So this is for students. So let's for now just create uh, a element name which can have maximum 30 characters. We will use this element or um, string or character array to store the name. And as I said, uh, this structure, we need a one more element which should store the address of next element. So it should be of a structure type only, structure student next. This is also called self-referential structure. This whole thing we also call self-referential structure, because this structure is referring to itself, and this is required. This is fixed. This is fixed. You will see in all the programs of single linked list. Like, we'll have one variable which will store address of similar type of structure, and here this varies. Here I'm just for now I'm taking name, but since we want to store all the information in student, we will have few more names like, or variables like date of birth, father's name, mother's name, contact number, address, and etc. So let me proceed. So this is the structure, and I am just using semicolon to terminate it. Now after this, what I will do is I will create basically two functions for now. Void add student, and similarly I will add one more function, void display all students. And we can have we can say delete all notes or all students. So since we are, the linked list is for the linked list we create a runtime memory using malloc, and that runtime memories are located from heap. So for each student we will be allocating memory of heap, so we have to make sure when we are closing the program we are erasing all the memory. That will avoid memory leak. And as usual I will have one more function, integer name. In old compilers we can just say void main also here. Instead of integer we can have void, but the latest compiler will throw an error if we are using void main, and we can say return 0 for now. So here what we will do is we will create a menu based program where we will ask user what does he want to do, whether he wants to add a student or he wants to display all the stored students. So let me for that we can create a choice variable. We'll say 1 and while choice is not equal to 0, until someone enters 0 we'll keep on displaying the menu. So we can say printf main menu, just a normal message, and then we can say /t. We can use /t as a tab for spaces. Press 1 for 1 to add student. Similarly, let's say we have one more functionality, that is you can do to display all students, and we can say 0 to exit. Now we'll ask user to input his or her choice. So we should set printf into your choice, and we can scan up. So choice is integer, so we should use %d, and we can this is variable, integer variable, so you should have percent and choice. And now whatever user enters, on the basis of choice we have to call these functions which we have declared on top. So we can use switch here, and switch we can pass this variable, and inside this switch we can have like case, and the value of choice is 1. This will call some function that is add student, and we have to make use of break, so that is mandatory, and case 2 display all students break, and if I say someone says 0 we have to exit the program. And if someone presses anything else, that is default case, we should say message, we should show a message invalid choice, please input a valid number. And basically after showing this message on the screen, we should wait for user to press some key, so we can use getChar just to hold this. And after this, okay, once we come out of this switch we will be in while loop, and if some wrong input then it will print this message on the screen, and after that it will come out of switch and come back to here, and it will print the menu again one more time. Okay, let me make sure the function name: add student, display all students, delete all students. Okay, so the basic structure of the program is done. So we'll modify the student method. So since there are three functions, we have three functions, and three functions should all will be accessing our linked list or structure variable. So let's create a global variable for the. So in node linked list we have two types of pointer. We have a head pointer which always point to the very first node, and tail pointer which will always point to the very last node. So let me create those pointer in global scope. I can say struct student uh, head, and by default it will be null, and similarly struct student tail is also null by default very in the very beginning. So now let's come to adding a record. So two things, when we are adding very first record or very first student or very first node, we should check if head is null. Head is null means the linked list is empty. Head is null, then it means linked list is empty, or we can say that is no record. So in this case head will be always null. Head is not pointing to any node. Now it's time to create a new node. So what we can do is we can create a new node here only before it. Struct student temp is equal to, so as I told you, we need to, in linked list we do allocate memory for each node using malloc, and the number of bytes which we need to allocate we have to pass in malloc. So how can we calculate? We can make use of size of operator, and we can pass here struct student. So okay, so we have a new node created on temp, and temp is pointing to that. Okay, so let me show you how does it look like. So basically let me present something. So we have one node here. Let me draw something like this if it will help. So we have a node, new node. It has two things, two fields. One is for name and one is for next. Okay, and this TMP pointer is pointing to this guy. So this has been created in memory. Now after creating this we will assign some value to it. So let's say in the name we will call it, just for example we say Nui, and next. So remember, next always hold the address of next node, but we don't have any next node here, so in that case it will be null. And head should point to this is first node, and tail also should point to this, tail pointer should also point to this. Okay, let me go back to the program. So we have temp, and after just creating temp we should make its next pointed to null. We can do this always. So we created a node, it will have name and the next, but we don't have the next node yet, so it should be null by default. So now coming here, we created here in this area we created a node, and temp pointer is pointing to it. Now we are seeing head is null. It means this node is very first node. If this is very first node, then head should always pointing to this node, and tail should also point to this node. So it means if the node is if we don't have any node in the past and we are creating new one, then that node will be very first node, and head and tail will point to that node. Now in the else scenario, where we already have one node or more than one node, so let me show it by example. So this is the first node we have here, this thing. Okay, now if I create one more node, let me create one more node. Let me create here. Let me create one more node. So remember, each node we are creating, it has some address. So let's say this first node has 0x100 address, and this has 0x999 address. For example, I'm giving you address, but you can print it and see what is the exact value. So when we create a new node using malloc, it will have two blocks. In the next, after allocating memory for it, next we are always setting to null by default. Now this is the first node, this is the second node we have. Head is pointing to it, tail is pointing to it. Now but when we are creating new node, the tail should not point to here now. It should always point to the second node. And as I told you earlier, the next part, which was null here, this will always store the address of next node, that is 099. So it will not store null now, it will have 0x999. So that is how it will link to this node. That is how linking is done. Each node in single linked list, each node store the address of next node. Now let me go back and we can give it some name, like we can say Andrew, any name we can give. Let me go back to the program. So here this asblock means we already have some node. Now we already have some node already created. Okay, so in this part what we'll do is we will say head next head. Head means head was pointing to this node here, and the very first node we create a new node. So what we'll do is we will say head next of head equal to address of this second node. So we'll do like this: next of head, or heads next will always have the address of next node, which is a new node, which is just TMP, and we will mark tail equal to TMP. Tail will point to the tail will always point to the the new node. This is how we will do. This is how we can create. Now we have added this. This function will take care of first node, and afterwards it will take care of all the nodes. It will keep on adding. Now what if we want to display? Now we'll come back to the second function, which is display. In this function what we'll do is we'll create a struct node, one more temporary pointer. Using this function, using this temp, what we'll do is we will take a pointer TMP here, and we will point it to very first node, and we will start from here. Once it is done with the printing of first node, then it will point to the second node. Likewise, it will point to the third node. It will keep on changing. It will keep on moving. It will keep on iterating from one traversing from one node to next node, like that. So if I stamp will point to the, so we need the reference of very first node, and that is being pointed by head node. And we can say here, if we don't have anything in the head, that we need to handle. If head is equal to null, then we can say printf no record or link list empty. Else, in else part we can just keep on printing. How we can print is we need a while loop. Actually we can also make use of for loop or do while, but it's easy to just say while loop. While TMP is not is equal to null, this while loop will keep on running, and TMP is not is equal to null, then we'll just print it. So So using this pointer, we will um, using this TMP pointer, we will point value of name. We'll say name %s and temp name, whatever the value of this. So it is name small. I'll print like this. And after this we need to move this temp, right? So don't forget to temp is equal to temp next. So now temp will point to the next one, and since this is loop, it will keep on happening. So now this is done, this is done. Let's try to compile. Okay, let me come out of this file, escape, shift semicolon, right, and quit. Let me compile this using GCC. Okay, so many errors. We'll solve one by one. So first thing is get chbar. I'm using get. It should be get care. Exit, we should have a header file for exit. Invalid, temp next. Temp next. Define type is struct, no. Okay, go back. I'll open this file again, and I'll go back and check what is the structure. Struct student care name. Student. Okay, there's a mistake here. There's a typo. And student, this is good, this is good. Oh, this is not node, it should be struct student. We can type that this structure. I'll show you once we are done. And this is that, it should not be get ch, it should be get care to hold the screen. Let me save it again and compile it one more time. Let me clear the screen so you can see it. So now student has no member next. Oh, it should be in capital. That's right. Let me open this file one more time. And where was that? So this has element next. We have to make sure we are using next everywhere. Where is next? Should be capital next. It looks like I missed it. Okay, here it is. I'll change it to next. Let me save it. And we were getting one error for exit. For exit, it's better we can include the header file. I believe header file is stdlib.h. Let me save it and let me compile one more time. So we'll try to assignment. We should try to remove all the warnings. Incompatible pointer, struct student pointer to tab. Student pointer tab, and second is same error. Let me check struct student. This was load actually. We can ignore those errors for now. We can try to fix later on. So it was compiled successfully. I can see by if I do ls, I can see a file, a binary has been generated. Now name it properly. Delete this binary for now and compile it with the proper binary. -o means -o means object file. Student reg.out. It should be GCC Warnings we are ignoring for now. If I do ls space hyphen ltr, we have the binary. So if I run this binary, then we will see the behavior and student. Okay, we have the menu here. At press 1 to add student, press 2 to display all display all. It should be all. Is a typo. Let me try adding first. So I'll just say Rui. Oh, we are not calling the function. Looks like nothing is happening. It says 0. I came out. Let me go and check what is happening in the file. Switch scanf twice case 1 add student. What is wrong here? Add student. Oh, we did not ask for any information in the add student. Okay, it's better to, here we can do like printf into any name or name of the student, and we can say scanf percentage s. This scanf will have some problem. I'll show you what. And name is just character array, so we don't need ampersand. This name will have some problem. I'll show you. This will not work when we have spaces in the name. We'll try to fix it later on. Let's just run it. Let me compile one more time. What is his name? Sorry, my bad. It should not be. It should be temp is pointing, so it should be temp arrow name. Let me compile it. It got compiled. And if I run it one more time, see, into the name, I will just say Rui, and I'm done. I will add one more time. I will say Anthony. I will add one more time. I will just say David, and here versus display. You see here, if I do display, it printed Rui David, but we entered one more time. We entered two names, Rui. We entered three names, Rui. We entered one more time, Anthony and David. But when I'm printing, why I'm seeing only two records, Rui and David, first and last? Why we are not seeing the middle one? Let me add one more. Now I'll add a name here. Let's say Cornelius. Let me print it. So it is always printing the first and very last record. We need to fix something. I will say 0 to exit for now, and let me edit this file one more time and see. In the print we are having some issue. This is temp is pointing to head. Okay, and while temp is not is equal to null, we should say temp is equal to temp next. This looks good, and temp is equal to temp null. Okay, this is good. Then something is wrong here. First and last node, if this is null, then head and tail both are pointing to temp, else head next is equal to this and tail is equal to temp. This looks good. And name tail adding one student, I'm adding temp name, temp dot next equal to null. head is null, then head this new node head will point to the temp, and tail will also point to tail, and if not, then head next is equal to temp and tail is equal to temp. Display no, this is something wrong. It should be tail next is equal to temp and tail is equal to temp. This is the right one. There's a mistake, sorry. Let me compile one more time. You can ignore the error. I'm clearing the screen. Let me run it. I'll add one more time. I'll say Anthony. I'll one more time. I will say David. I'll add one more time. I will say Cornelius. I will display. It should display 3 records. We have 3 names. That is good. Let me add one more. I will say Rui. And if I display, I should get 4 records. So this is working fine. Now I was talking about the what if we enter name with spaces. Let me do one more time. And let's put it Sean. Sean. Sean Boss. And if I enter and then I display, you will see it is taking 2 name Y, and this is the issue. What I entered is taken separately, and this is completely wrong. So to fix this, I'll just exit from here. I will add this file one more time, and when I'm entering into name, so remember, if we have spaces in scanf, or if we have spaces while entering name, scan will completely ignore the value after space. So for that, the trick is so we should say scan will keep on reading until it see enter or next line character. For that, we usually like this /n. So this will keep on reading until it reaches next line or entry. /n is next line. And after this, let's see what happens. We'll run one more time. Let me compile this program one more time. Clear the screen. I'm running. If I run one more time, Rui Carvalho. If I just display 2 for display, then it's printing Rui Carvalho. That is good thing. If I enter one more time, I just say Anthony Douglas, and if I display one more time, it will display. But if you see here, why we are having these extra name here, just blank name, I tell you why. Because in the scan we are reading until we get new line character. That new line character is becoming part for the next input, next input, that is input for the next name. Let me fix it. If I add it one more time, and to fix that, what we have to do, we have to make sure that the next slash n character is not reaching to the next input. So for that, you can just say get char. Basically, this will take care of that issue, and we will not see new line character becoming the input for the next input. I'm saving it. I'm compiling it one more time. It got compiled. Now I'll clear the screen and I will run it one more time. Add, and I say record. If I say display, it's again displaying. Something wrong here. I know why. Let me figure it out. I will exit. And maybe see, it will come from the bottom. We are entering here. After entering, we have slash n in the input. So we entered here. So this is scanf. We'll have extra slash n, and that slash n is there in std in stream, and when we are reading the name very first time, it is becoming part of this scan. So okay, do one thing. Before this scan, just do get char. Maybe this will read the slash and it will ignore becoming part of this scan. I know this is very tricky, but you'll come to know if you practice a couple of times. I'll save it, compile it, clear screen, let me run it, and now let's say record. If I enter and just display, do for display, see, I did not get that extra name in the beginning. So let me add one more time. Anthony D, and I will add one more record. David G. So we have 3 records, printing 3. So this is good thing. Now you remember all of these information we are storing in linked list, and this linked list is created at runtime. So when we exit from the program, this linked list will be erased, because if we are coming out of the program, all the memory allocated for it is erased by the operating system. So so that we can try as an enhancement, we can store this information in text file as well. So when we start the program, we will read all the data from the text file to the linked list, and when we are adding, we'll add new data to the linked list, and then before exiting from the program, we will save or we will dump everything into the same file to update it. So that way we can maintain the data every time we launch or exit from the program. But for here, let's create few more variables and try to modify this, modify the program. I will exit from here and clear screen. If I come here, so in the exit, we are just exiting from the program, but we are exiting, and before exiting, we have to make sure we are releasing all the memory allocated for nodes. So let's say we have 4 names. Last time we entered 3 or 4 names. That means we have allocated memory for those 4 nodes. Each node is storing how many bytes. If this is 32-bit system, then this is 30 bytes and this is for 34 bytes. So this one, okay, we are not worried about the memory, but we have to basically delete all the nodes when we are done, or whenever we want to erase all the data. So here we'll just create like before we will declare one temp structure that will point to the head node, and we'll say if temp, or instead of just first declaring, just check if head is equal to null, then we can say linked list empty, else In this part we will say we'll declare a pointer which should pointing to the which should point to the very first node. If temp is equal to head is very first node. Basically head always point to the first node, so we can make use of head, and we can say while temp is not is equal to null. So when this while loop runs very first time, it will say yeah, temp is not is equal to null if we have nodes, and then we'll say so this is tricky part. So we can say okay, so this is not is equal to null, and basically we want to delete this current node. So basically we should, for the free we should just say free tmp, but if we free this node, then we will lose the reference of the next node. So in that case, one option is to declare or have one more pointer, which we will call it where this will hold the address of next before deleting it, because on the next line we are deleting it. So next line we are deleting it, we deleted it, and now after deleting, my temp should point to the next node, and next node address we have in where. We can do like this. This is how we can delete, and to make sure how many nodes we deleted, we will create a pointer here. You can say unsigned long is equal to 0, and here we can increment the counter, and after this we can say number of nodes deleted %d, and you can say count here. Let me run this program. Oh, before running it, I have to make sure I'm calling this function in the exit. So before saying exit 1, let's call this function. So one important thing, see, we are exiting here, so when we are exiting, we don't need to worry about, see, it's good practice to delete, but in this case, if we are exiting from the program, then even if we are not deleting all the nodes, operating system will release all the memory. But it's good practice, we are exiting here on this line and trying to delete, but we can have one more option in our menu saying that delete or erase all the records or delete all the records. There also we can call this function. Okay, so for now let's add it here before exiting from the program and save it, compile one more time. Oh, sorry, it says function delete or student, something wrong with the function name. Let me read it. It is delete all student. But I put extra s here. Let me delete it. Let me remove this. Let me compile one more time. I compile count. Okay, that is count is, if you see here, this count is unsigned long int. It's good. It will count, treat it as integer only, but it's good practice to put it here. And here, since it is long int, we should use ld. Let me clear the screen, and if I compile, it got compiled. We can ignore these errors for now, and if I run, I will see the menu. But before menu, let me clear the screen. Okay, let me run this program one more time. I say one to add, I just say Rui, Carvalho, and I will add one more time. Just say David M. So I have added two students name. So let me display. So I press 2 and I can see two name here. Now when I do exit, so if you see here we have two names. It means we have two node and we just have name of the student in the node. So that's okay. We have two nodes, and if I'm executing, our new function, that is delete all students, should call, and that should delete all the nodes from the memory using free function, and it will display the count as well. So let I am pressing 0 and enter. You see here it is coming down below the recording area. That's okay. Deleted student, I can press enter. It will say 2 number of deleted node. To make it better, let me fix the code and number of deleted after this. Next, let me put next line character to be better, and I can highlight it by printing star, something like this. I'm good now. So now this was basically just storing name. Let's store something else as well. So we have name. It will look better. Let me store like date of birth, and date of birth, how many characters. So it should be, we will do like this, mm/db/yyyy. How many characters? If I count here, 1 2 3 4 5 6 7 8 9 10. These are 10 character, but we need one extra space for the null character. That is good practice. So this should be 1 2 3 4 5 6 7 8 9 10 11. This should be enabled 11. And similarly, let's store something as, let's say, father name. Let's make it 30 for now. You guys can change it according to your need. And we'll say mother name. This is also 30 for now. Then we'll say contact number. Let's make it 20. Let's make, what about the address? Let's make 50 characters. This is for the address, and that should be good. Now this is information. You guys can add few more elements or few more information if you want. Now when I'm taking input, I have to make sure I am asking for everything. So enter name. After entering name, after get care, yeah, I will say one more time, printf, enter date of b. I'll just say, I will specify the format in the bracket, mm/dd/yyyy, like this, and I'll say scanf. So this will not have spaces, so we can just say %s, and we should say temp dob. Similarly, after dob we had father name, and we should say scanf. So this father name can have spaces, so we have to make sure it is not taking next line character from the previous input. So we'll just say get care here also, and I will say %s, %s, in the middle of this I will put this one character, that is this one, and I will say temp dot father name, and I to hold or to avoid slashes like before we use get care here, or why don't you copy paste everything? So but don't copy paste everything for now. So we have name now. We similarly we have mother name, enter mother name, and we should use scanf percentage s, and we, because mother name can have spaces while entering full name, so we should use this, and pointers mother name. Similarly we can have contact number, scanf. Contact will not have spaces, so we can ignore it, and this will be TMP contact number, and address. Last one is address. Let me take input from user percentage s, but address can have spaces, so we have to make sure our scanf is not ignoring values after spaces. So I will say the operator /n, and I will say temp dot address. Okay, let's go ahead. Let me compile this. Oh, I hope there is no error. All these warning, there is one error. TMP DOB. Oh, the pointer name is TEMP, not TMP. Let me fix it. It was DOB. Oh, yeah, this one. Oh, so for better readability, you can always enable the line number by pressing shift semicolon set NU. So this way you can see the line number also. These VI commands I have already taken care in one of the video. If you check my videos of my channel, there's a video on VI editor in Linux. You will find these VI commands there. I have covered almost 50 commands. I'm coming out. I'll compile it one more time. What is this? Why did not I save it? DUB. Okay, DUB is here. What's wrong here? It should not be because of this single line multi-line comment. Something else is wrong. Scanf percentage s TMP DOB. Let me compile one more time. Let's go by line number this time. 29 TMP undeclared. Why it is not saving? If I enable the line number, you go to line number 29. Oh, there is one more mistake. TH is TMP. Okay, we fix two more. Let me compile one more time. It got compiled. We can ignore this error for now. And if I run 1, let's put single name, first name only for now. 02. Sorry, let's say the month. Month is 10th month, 10th date, 1990. Father name. Let's say Anthony M, just Anthony. Mother name, let's say Suzanne. Contact number 708767122. Okay, I saw this. If I just say display, it will display me the record. Oh, why it is okay? I see why it is printing just name, because we haven't printed everything in the display in the display function. Let me go out of it. Number of node deleted because it had only one node. Let me clear the screen and open that file. So in the print tab, display all record, we are just printing name here. So and additional to this, we can print DUB after DUB, what was that? Father name, I think is father name. Mother name. After mother name, contact number we were printing. After contact, I think we had just address, right? So let me print the address as well. Okay. So okay, this one. So we have how many? See, 6 field, like name, date of birth, 2, 3, 4, 5, 6. Okay, we are good. Let me compile. Let me see if it has any compilation error. No error, just warnings. I will clear the screen. I will run one more time. I'll add Roy 10 10 1992. Father name Anthony. Mother name Suzanne. Contact number 708 717 621 222. Why it did not ask me for address? See here. Okay, let's don't just print it for now. We'll take care. See, it printed everything except the address. I think that enter is creating problem, like new line character is getting mixed up with, it's getting passed to the next input, that is address. Let me try to fix it. Let me exit it. If I clear the screen, let me edit the file. Okay, let me go to the input. What is happening with the address? So okay, so here after this, here there will be an extra. So here to take care of line character, we should see get care. But the problem is the address, and address it did not pick the address after entering the contact number. So for better, let's put get care here also. Let's see. Let me compile the program one more time. No error. Warnings. Warning we can ignore for now. Students record. Add Rui 10 10 0 1992. Father name Anthony. Mother name Suzanne. Contact number 708 767 222. Now we are getting address. So we will say I will enter part of the address of my friend, 97 Mineral Spring Lane, Virginia, USA. I hope this is this is not more than 50 characters, otherwise it would be ignored. Something will be ignored. We'll see. Let me just say display. So that's fine. Let me add one more. I'll just say one more entry. Enter name. Enter name. We'll say just Cornelius. Date of birth 01/01/1990. Other name would be Sean T. Mother name, let's say mother name will say Makra. contact number 708-761-1222, address say Oak Forest, Chicago, Oak Forest, South Chicago. If I just say 2, and see everything well, 2 records printed here. Okay. For the better readability, we can while printing the next record, we can separate it by dot line. I will show you, but before that, if I just say exit, it will delete 2 nodes because we have 2 nodes in the program. So that is working as expected. Let me clear the screen. Let me go back to the program. And while printing after this, here we can say after printing everything, we'll say okay, we should not print here, otherwise even if it does not have, it would print, even if it does not have single record or node, it will always print something. You should print here. We'll say we will hold the screen. Okay, we'll say printf, press enter key for the next record, like this. It will look better. And before this, I will just say dot. Okay, let me save it and let me compile it one more time. No error, clear screen. Let me run it. I just say 1 v 10 10 0 1992. Father name Anthony G. Father name Suzanne. Contact number 708-712-86. Some contact number. I'm not following exactly. 4097 Mineral Springs Lane, Virginia, USA. Okay. I will add one more for now to make sure that it's the last chain is working as expected. I'll say string name, timer. I'll say 01011995. Other name will say just David. Other name will say Makra. Contact number 708-765-1222. Some contact number. Address will say Oak Forest, South Chicago, USA. Now let's see. It printed both of the records, but I don't see the new line character. Maybe did not I save? Okay. Let me check it one more time. It is here. So, oh, I'm sorry, I printed here. My bad. Let me delete from here. I'll just say double D. I'll come down here and I'll print here. And I should check here. It should not print all the time. I have to make sure this is not last node it is printing. Otherwise, it will print the last node and it will say press enter key 2 for the next record, and actually there is no next record. Temp is not is equal to null, and then we'll print something. Press enter key for the next record, and we'll just separate each record, and I will hold the screen so that once I press enter, then only it will show the next record. So let me clear the screen. I will compile one more time. Let's see, there is no error. I clear the screen one more time. I'm running it. I hope this is last time. Okay. Add record. Read 10 10 20 1992. Father name, let's say Anthony M. Mother name Suzanne. 708 7671 222 222. Address 4097 Mineral Springs, name Virginia, USA. And let me have one more record for now. I'll just say now David date of birth 0101. Let me minimize the screen, then it will be better. 01 2020. And minimize the screen does not work properly. Okay. Father's name I will say Timer. Mother name Makra. Contact number 708 712 6445. Address Forest, South Chicago. Enter. If I just display, see. Oh, it display each record, but it did not ask for us. It did not wait for the next record. It printed enter key, but it printed. I know why. Let me exit. Let me clear. I know why, because when we are entering here, maybe after the last input was this one. Enter address. After address we have to observe the we have to take care of slash, and it should not become the input for the next input. We'll try one more time. Enter. I'm just running. Add student. Rui 10. This time I want to be a little faster. And father name let's say Anthony M. Mother name Suzanne. Contact number 708 712 6227 something. Address 4097 Mineral Springs Lane, Virginia, USA. I will add one more. I will say Timer. His name is Timer. Date of birth 01/01/2020. No, it's too early. 1990. Father name as you say David M. Mother name Makra. Contact number 708 6662522. Enter. Address Let's say South Chicago, USA. Something wrong. Okay. Oh, it asked me to enter 2 times. Enter. Okay. If I just display, that we need to look why it is not holding, why it is not waiting for get care. I just exit. See, it has 2 records. It's printed 2. That's why. We'll go quickly and I'll see if I can quickly fix it while printing display or record. Get care. Okay. There's some minor issue with the program, but to fix this we can quickly add one more get care and try this. You guys can try it. For now I'm not improving this program. So this program you can download from the link given in the description. You can modify it as per your requirement, but remember we are saving everything in the linked list, and when we come out of the program, everything we lost, everything everything is erased or deleted from the memory. So in the next video, we will we will improve this program by saving everything into a text file. At the end of the program, we will say, before exiting from the program, we will save everything, all information which we have in linked list. Like, we'll save everything, every information from linked list to a text file, and we are launching the binary when we are opening the program again next time, or again the next time. We will read everything from the text file and load into the linked list so that we can operate on it. We can delete the data, we can manipulate it. So many options we'll try. We'll also, in the next video, we will also try to search the student by name. We can search them by contact number, we can search them by address. So those kind of feature we'll be doing. I don't have I have to stop now because it has been more than an hour now. Thanks for watching. For you, this is for information, this is a language machine. Basically, I have created a virtual machine using Ubuntu operating system. Yeah, that's all for today. Thanks for watching.